Today, we're going to explore the famous quote by Carl Sagan. The cosmos is within us. We are made of star stuff. We will dive into what this means and how scientists learn this amazing fact that connects each and every one of us. Thank you for watching. Let's begin. This quote is a simple and powerful way of explaining some of our earliest origins, as well as our connection to each other and the world around us. So what exactly does this quote mean? Well, StarStuff is referring to stardust, which is the name scientists give to the tiny grains of dust that are scattered throughout the universe. These dust grains are not ordinary dust, like the kind you find on your furniture. This dust is made of atoms that were forged by nuclear fusion inside of stars billions of years ago. Stars are the ultimate alchemists. They take the simplest and most abundant elements in the universe, hydrogen, and fuse it into heavier elements such as helium, carbon, oxygen, and so on. This process releases a tremendous amount of energy, which makes stars shine and radiate heat. But stars are not immortal. They have a finite amount of fuel, and when they run out, they die. Some stars die quietly, while others die in spectacular explosions called supernovas. When a star dies, it ejects some of its material into space, forming a cloud of gas and dust. This cloud is rich in the elements that the star produced during its lifetime. Some of these elements are the ones that we need for life, such as carbon, nitrogen, oxygen, and phosphorus. Others are the ones that we use for technology, such as iron, copper, silicon, and many others. And some are the ones that we admire for their beauty, such as gold, silver, and platinum. These clouds of gas and dust are the nurseries of new stars and planets. Over time, gravity pulls the dust grains together, forming larger and larger clumps. Eventually, these clumps become so massive and dense that they ignite a new star at their center. The leftover dust forms a disk around the star, where planets, moons, asteroids, and comets are born. Our solar system is one of these stellar families. Our sun is thought to be a third-generation star, meaning that it was born from the ashes of previous stars, and our planets, including Earth, are made of the dust that surrounded the sun when it was young. That means that every atom in our bodies was once inside a star. But how do scientists know this? How can they trace the origin of the atoms that make up our world and ourselves? Well, one way is to look at the light that stars emit. Light is composed of electromagnetic waves of different wavelengths and frequencies. When light passes through a prism, it splits into a spectrum of colors, from red to violet. Each element has a unique fingerprint in this spectrum. By analyzing the spectra of stars, scientists can determine what elements they contain and how much. This process is called spectroscopy. Another way is to look at the dust itself. Some of the dust grains that were ejected by dying stars are still floating around in space, and sometimes they enter our atmosphere as meteors. When they do, they leave behind a trail of tiny particles that scientists can collect and study. These These particles are called presolar grains because they existed before the sun was formed. They are some of the oldest solid material in the solar system, and they too carry the signature of the stars that created them. By measuring the isotopic ratios of these grains, scientists can tell which type of stars they came from and how old they are. Isotopes are different forms of the same element, with different numbers of neutrons in their nuclei. For example, carbon-12 has 6 protons and 6 neutrons, while carbon-13 has 6 protons and 7 neutrons. Some isotopes are stable, while others are radioactive and decay over time. By comparing the abundance of different isotopes in a grain, scientists can estimate when and where it was formed. Using these methods, scientists have discovered that some of the presolar grains in our solar system are older than the sun itself. They date back to the early days of the galaxy, when the first generation of stars were born and eventually died. Some of these grains are more than 7 billion years old, almost twice as old as Earth. They are the remnants of ancient stars that we will never see, but that live on in us. Life on Earth depends on the availability of the elements that have been traced back to stars, especially carbon, hydrogen, nitrogen, oxygen, sulfur, and phosphorus. These are the 6 most common elements of life on Earth, and they make up the vast majority of our bodies. Life also needs trace amounts of other elements, such as calcium, iron, magnesium, potassium, sodium, and zinc, all of which came from stars billions of years ago. These elements are essential for various biological functions, such as building bones, transporting oxygen, and regulating nerve impulses. Life obtains these elements from the environment, either directly or indirectly. Plants and some bacteria can capture carbon dioxide from the air and water from the soil and use them to make organic molecules through photosynthesis. Animals and other consumers get their carbon and water by eating plants or other animals, as well as drinking water. Decomposers, such as fungi and bacteria, break down organic matter and release carbon dioxide and water back into the environment, completing the cycle. Nitrogen, oxygen, sulfur, and phosphorus have similar cycles involving different processes and organisms. Plants absorb these compounds from the soil and use them to make amino acids and nucleic acids, the building blocks of proteins and DNA. Animals get their nitrogen by eating plants or other animals. Nitrogen is returned to the environment by decomposers who break down organic matter and release ammonia, or by denitrifying bacteria who convert nitrates and nitrites back into nitrogen gas. Oxygen is produced by plants and some bacteria through photosynthesis and is used by most living organisms for cellular respiration. Oxygen is also dissolved in water and is essential for aquatic life. Oxygen is returned to the environment by respiration, decomposition, and combustion. Sulfur and phosphorus are found in rocks and minerals and are released into the air by volcanic eruptions, human activity, weathering, and erosion. Sulfur is present in some organic compounds, such as amino acids and vitamins. Phosphorus is also present in some organic compounds, like nucleic acids. Sulfur and phosphorus are taken up by plants from the soil and are passed on to animals through the food chain. They are returned to the environment by decomposers who break down organic matter and release these elements back into the environment. So you see, the elements that we need for life are constantly cycling through the Earth's systems, and we are part of that cycle. So the next time you look up at the night sky, remember that you are looking up at your ancestors. We are connected to them by the atoms that we share, the atoms that make us who we are. We are all made of stardust, a part of a cycle that will continue on long after we're gone. Thank you for watching. I hope you enjoyed today's video and learned something new. If you did, feel free to show your support with a like or by sharing this video with someone else who may enjoy it. I would also love to hear your thoughts in the comments. If you would like to see more videos like this in the future, feel free to subscribe. Thanks again. Until next time, take care and be well.